Hi and welcome to Algebra 1. This is Chapter 1, Section 4, Properties of Real Numbers. First thing we're going to talk about is equivalent expressions. Now, with equivalent expressions, you have something that is like 2 plus 3. Let's do a really simple example. And I find something that's equivalent to it as 3 plus 2. So each side equals 5. It might look a bit different in the way that it's ordered, but basically it's the same both sides. It also works the same for something like a variable expression or an algebraic expression. You might start off with 4x plus 2, but you can also have it as 2 plus 4x, and they would be equal to each other. So let's talk about commutative property of addition. That would be very similar to what I just did. 2 plus 3 equals 3 plus 2. What happened was that you can see that the order of the 2 and the 3 got rearranged. So where the 2 was first, it's now second, and with the 3 it was second, now it's first. So they basically commuted positions, they swap positions, and you still have the same thing both sides when you add them together. The commutative property of multiplication is similar, is just that we have multiplication instead of addition. So if I had 2 times 3, and I was asking you to use the commutative property, you would put, what do you think? Yes, you would put 3 times 2. Both sides equal 6, so they are equivalent expressions, but they're just rearranged. So, next thing we need to talk about is the associative property of addition. That's where we have something like 2 plus 3, which is grouped together. And let's say I want you to add 2 plus 3 together first and then add 4. Well, really, you could rearrange this. You could still have the 2 plus 3 plus 4, but instead of putting the parentheses around the 2 plus 3, you could put it around the 3 plus 4. Either way, you'd still end up with the same answer, 5 plus 4, which is 9 on the left-hand side, and on the right-hand side you'd have 2 plus 7. So they both sides equal 9. It's just that you might have arrived at it a little bit differently. For the last property here on the bottom, we have the associative property of multiplication. Again, it's the same idea. You might have 2 times 3 times 4, and the 2 times 3 might be in the parentheses, so what I'm asking you to do is 2 times 3, multiply those, so you'll get 6 times 4, which is 24. But you could also have 2 times 3 times 4, but the 3 times the 4 is put together. So I'm asking you to find twice 3 times 4. 2 times 12 is 24. So both sides equals 24. You just came at them a different way. Okay, the next thing we have is the identity property of addition and the identity property of multiplication. And basically identity means that you end up with what you started with. So, identity property of addition, what would that be? That means that if you take a number and you add 0 to it, you end up with the original number. So, let's say we had 2. 2 plus 0 gives us the original number 2. And it works with variables too. So if we had y plus a 0, we'd end up with the original y. The identity property of multiplication says that if you take a number and you multiply it times 1, you end up with the original number. So let's use good old 2 again. 2 times 1 gives you 2. Now you're going, hang on here, I already knew this. I just didn't know that it was called something. Yes, it's called the identity property of multiplication. And again, it works for variables. So let's use our y. Y times 1 equals y. The next one is the zero property of multiplication. You can probably guess what that already is, but if you take a number and you multiply it times 0, you get 0. That's pretty neat because you can use that for numbers and variables. It works every time. Pretty neat, even if you have something really complicated like x plus 2. If you multiply that times 0, you get 0. A handy thing to remember. The last one on this page is the multiplicative property of -1. And basically it says if you take -1 and you multiply it times a number, you'll get the negative of the number. So let's see an example. -1 times, let's choose 2. 2's positive, right? So negative 1 times 2 gives you negative 2. Oh, so it gives you the opposite of the original number. Pretty neat. And let's choose a variable. Let's do a z this time. Now when I draw my z's, I put a little line through it so you can tell the difference between my 2's and z's. And so when you multiply negative 1 times positive z, you get a negative z. So here's my question for you. What do you do if you have a fraction that's 3abc over ac? Well, the first thing we want to do here is we want to split this up so that we have our 3 times our a, and what we're going to do is we're going to put the a in the denominator underneath the a in the numerator. Then you'll see we have a b, and b is multiplied times c over, look, there's another c in the denominator. So I've split these up so that I can then go and use the division property, which says that a number divided by itself is 1. So this cancels out to be 1, this cancels out to be 1, and so do the c's. That's kind of neat, because what we've got left now is we have 3 times 1 over 1 is 1, times the b, times c over c, which is 1 over 1, gives us 1. And then finally we can multiply this together. 3 times 1 is 3, times b is 3b, times 1 is 3b. So that's how you cancel out these, what look like, quite difficult fractions. They're not really that bad. So let's see how these properties apply in real life. Movies, anyone? Love the movies. Let's say I buy a ticket for $7.75, a drink for $3.50, and popcorn for $4.25. Now, if I don't have a calculator on me, I'll be going $7.75 plus $3.50. Well, that's 10 plus 75 and another 50. That makes 11.25 plus another $4.20. That's 15 something. Well, you know what? I think that instead of adding them together like I just did, $7.75 plus $3.50 plus $4.25, it might actually be easier for me if I use the commutative property of addition and I swap the $3.50 and the $4.25. So let's go ahead and add $7.75 plus $4.25. Oh, that's a lot easier because you add the 7 and 4 and then another $1 for the 75 cents and the 25 cents. That would be $12. Plus $3.50 would make $15.50. Oh, that was a lot easier. And I didn't have to rack my brain trying to think of which combination goes better together. So yes, you can rearrange the way you add things to make it a lot easier. Well, thank you for listening, and we'll catch you next time. Bye.